Hey guys, quick little video here, how to use Excel. I've heard some feedback from people and some of you have never used Excel before, which is kind of scary considering you guys are in grade 11. So I'm going to give you a quick little tutorial, kind of focusing on how I want you to be using Excel here in physics. Excel is an accounting software mostly, but you can use it for analysis of any data. So we're going to use it today quickly to look at two things. We're going to be doing basically how to use it to do calculations, repetitive calculations, and how to use it to come up with graphs, and from the point of view of our lab. Okay, so spoiler alert, there will be numbers used from the lab here. So if I go to my data set here, this shows me my data here from the lab. All right, so this is the lengths from 10 centimeters up to 100 centimeters, and this is I'm calling it T20, the period of 20 oscillations. Now I need to come up with a graph here for period versus period versus length. Okay, but the problem is these periods are in centimeters and these periods are for 20. So first of all, I have to change these numbers. Now we're not going to get rid of these numbers, we're just going to do some calculations on them. So I need an extra column in between these. If I right click on B, I can go insert, and it automatically gives me a new column here. And I want to turn these into meters. So divide by 100. First of all, let's call this L subscript M. Okay, that's going to be my length in meters. Now if I hit equals, this allows me to do calculations on any of the cells in my sheet here. Now I can either click on A2, or if I just cursor over, A2 is now selected. Okay, so A2 is my thing. Now I'm saying this is saying that B2 is equal to A2. I don't want that. I want it to equal to A2 divided by 100. Okay, so if I have this little slash, that divides it by 100. If I hit equals, it does that calculation for me. And now if I wanted to do all this data, all this whole column, I just click on it, and there's this little box here, and if I mouse over it, it turns into a plus. And that allows me to drag that box and to do all those calculations for the entire data set. If you go through, this is A2 divided by 100, A3 divided by 100, looking up here, A4, 5, 6, and so on. Okay, so that's all of my data set, all of my lengths divided by 100. So all of my lengths converted into meters. Now I can do the same thing for my periods. I want one period, not 20. So I take my number, I go equals, I go in my next D2 here, I go equals, cursor over to C2, and divide by 20. So this is now the time it takes for one oscillation. Let's call that T up here. Okay, so that's my period for one oscillation, and this is my length in meters. So I have my data now that I want to graph. So let's take my data. I'm going to click over here, and if I hold down Shift and click on the last one, that selects the whole data. But I want this part here, and if I hold down Shift, I don't want these ones here. So this is a little trick here. If I click on the first one, pick that one there, and now if I hold down Control instead of Shift and click on these ones, I'm just basically highlighting the data that I want. So the length, the period, and I want to graph them. So I go up to the top here, I go to my Insert tab, Charts, and I choose Scatter Plot. Don't use line graphs. Don't use the connect the dot ones, only scatter plots, because we have no information in between them. Okay, so there's nothing physical about connecting the dots, only a scatter plot. So we've created our scatter plot of length and period. Now it's a little bit tricky because we don't know what's on which axis. So let's go up here to the plus, adding a chart element. I'm going to add titles. And on my y-axis, this was going from about 0.6 to 2, so that has to be my period. Period, measured in seconds. Make sure that when you label things, you put the units on. Without units, remember, cats per donut. And this was the length, measured in meters. Okay, and I can put a chart title. Remember, chart titles really should be down at the bottom, so you probably should just get rid of the chart title and then write figure 1 period versus length. Okay, now this is a non-linear graph. It's actually curving upwards. It's actually what we call a root graph. Right, this is a square root graph, right? Because we want actually periods squared. So this is my first graph. I think actually the fourth graph in the lab, but I now need to square the periods. So I'm going to take my column here, E. Let's do that. Let's find all the periods squared. So I go equals, and I take my D2 cell, which is the period, and I square it. That's that little hat, shift 6, and square it. And I click enter. I've done that, and I drag my little box down, and I've done that for all the data. Now if we do that trick again, I hold down shift, pick all my data, control, pick my other column, insert, scatter. There's the graph that I'm looking for. Okay, so this time, let's get rid of the title and add a label. So this time, this is period squared. Now, how the heck did I do that? Okay, so if you hold down shift and control at the same time, it makes all your numbers, oh, I did it again. If you hold shift and control plus, shift control plus, and then afterwards if you hit a 2, it is now a superscript. Now if you hit shift control plus again, it undoes it, and this is going to be in seconds, again, squared. Okay, and the bottom is still length in meters. Oops, meters. Okay, now I want to know what the equation of this line is. I need to add a line of best fit. The way you do that is you right click on any of the data points. It brings up this dialog, and you hit add a trend line. I'll give it a minute, and boom. Now it's highlighted linear, and as you can see, it's almost perfect linear. All the dots are just about on my data. Okay, and I want the equation, so if I just click down here, display equation on chart. So this is going to automatically, doing a bunch of mathematics, it comes up with a line of best fit. Okay, and you can even let's go back to format trend line here. If you really fancy, you can even add an r² value to tell you what the correlation coefficient is, but we don't need that. Okay, so we can tell just by looking at it how good a fit we have. Now this number 4.0163, that's the slope of the line, and that's what we want. That's my theoretical value I'm looking for in my lab, the experimental value I'm looking for in my lab. Anytime we have two variables and we want to look for a relationship, we can always linearize the data and come up with a linear equation which has a y equals mx plus b form, and our slope here is what we need. That's the piece of information that tells us the relationship between the two values. I think in this case it's 4 pi squared over g, I think. Yeah, I think it's 4 pi squared over g that gives us our theoretical value there. Okay, so we can have a theoretical and experimental, and we can compare them doing our error analysis. Okay, so quick little tutorial on how to do Excel graphs, how to manipulate the data sets. Right, we can do calculations. Again here, this is where our calculations are. We can make these graphs. Now you can take these graphs, you can right click on them, copy paste directly into a Word document. Okay, and same with this one, whichever ones you want, and you can put them directly into a Word document, into a PowerPoint, whatever you want. Okay, so Excel is not scary. It's just a very big calculator with a lot of cells, some data sets are very large, but here we only use only like 50 cells that we're going to use here, and we can make these nice pretty graphs and do whatever we want with them. All right, so hopefully that helps, and good luck, and stay safe.